Okay, this is the Unit 10 review. You need to have your formula sheet because we're going to use a lot of things that are on the formula sheet. So I want to go over that first. So on your formula sheet, this section under sequence and series, notice that AN represents the value of the nth term. Okay, so what that means is, I'll give you an example here. If I have the first term, the second term, the third term, the fourth term, okay? And for a sequence, let's say it could be as simple as 1, 2, 3, 4, okay? So basically I'm adding 1 each time. So if I said what is A sub 3, the third term in this example is 3. Okay. The next one is the sum. So the sum of all the numbers. So if we were to take our numbers in our sequence and we would add them up, that would be the sum. All right, and then we have represents the sum of an infinite geometric series, and that's here. That's this formula right here. This represents, you can see the symbol's the same, a sum of an infinite geometric series. So these guys go together. R represents the common ratio, so what I'm multiplying every time. And then D represents the common difference, which we had an example here of our common difference would have been 1 in this example. So what I'm adding each time. Just remember that for ratio, you can multiply a fraction. And for difference, I can add a negative number. Okay, so then we go down here to our formulas. So we have arithmetic on the left and then geometric on the right. So these first two, okay, these first two right here are explicit. So these are explicit formulas, okay, meaning that I could ask for whatever term. So if I want the 10th term, the 11th term, the 12th term, it doesn't depend on anything else. As long as I know the first term, which is A1, you might want to write that down because they didn't give you that. A1 represents the first term. Represents the first term, okay? And then your common difference, you can find the value of whatever term that they're asking for. Okay? And then the next one are recursive formulas. Okay, so these are recursive. Okay, so for recursive, this A sub n minus 1, I'm going to write that up here, A sub n minus 1. What that means is the previous term. Okay, so this depends on whatever the previous term is. So when you have your formula here, it depends on whatever the previous term is. So for example, what I mean by previous term is if I'm at the third term, the previous term would be 2. And then from the second term, the previous term would be 1. Okay, and these problems you really have to read what the problem says in order to know which formula to use. Sometimes they'll give it to you, but sometimes you actually have to figure out what it's asking you for. All right, and then these, the S we saw represent sum. So these two right here just represent the sum of an arithmetic series, and then over here this is the sum of a geometric. Okay, and then we have a sum of an infinite geometric series, but notice here that the R value has to be less than 1, and we call that convergent. Okay, any R value other than R less than 1 would be divergent. So for example, R equaling 7 would be divergent. Okay, So that's kind of the gist of this unit. Now you just need to practice all the different problems. Okay, so this you're allowed to use on the test, but you need to make sure you understand what each of these pieces mean. So let's take a look at the first one. Question on the review. Which of the following represents the arithmetic sequence? Okay, so that means I'm adding something every single time. So for each of these, you've got to say what's happening here. How did I get from 3 to 6? Okay, well, I could multiply times 2, all right, times 2, and then check here. Does that work? Times 2. 6 times 2 is 12. Okay, that means it's geometric because I'm multiplying something each time. Here, from 3 to 6, okay, I could be multiplying times 2, but then if I do 6 times 2, that doesn't give me 12. So then let's check something else. Let's see, if I add 3, 3 plus 3 is 6. If I add 3 again, 3 plus 3 is 9. So I'm adding 3 every time, so D equals 3. So that is an arithmetic sequence. Okay, so remember this means adding something each time. The common difference. All right, let's look at the next one, which shows 4 consecutive turns in a geometric sequence. All right, so geometric means I'm looking for a common ratio, okay, a constant I'm multiplying every single time. So how do I get from 9 to 7? Well, subtract 2, okay. So we know that that doesn't work because I'm looking for something I'm multiplying each time. B, so this is plus 4, so that doesn't work. Here, this is plus 1, so these are all arithmetic. And then if I look at this one, it looks like I'm multiplying 9, so 2 times 9 is 18, but make sure you look at the next one. So 18 times 9 is 162, so I'm multiplying times 9, so R equals 9 in this example, and D is the correct answer. Okay, so what are the value? This is your sigma notation, and you can actually do this in the calculator as long as you remember which buttons to push. So you're going to use math 0 for these, math 0. So let's try that. So go ahead and get your calculator. We're going to do math, and if you scroll down to where 0 is, notice it's the summation notation, or you could just press 0, and it looks exactly what you see on your paper. Except for this example gives you n as your variable, but I'm just going to use x, which is fine. Just, you could put x in there. You can use n as well, but I'm going to use x. So x equals 3, arrow over to 5, and then 2x minus 1. That gives you 21. So you're looking for the sum from 3 to 5 in this expression, 2n minus 1. All right, let's do another one, math 0. Again, I'm just going to continue to use x, arrow over 6, arrow over 3x, and it's to the power of 3, so I'm going to use the caret, arrow over minus 20. That gives me 1624. Keep going, same thing each time. Math 0, x over, 9. Now be careful with this one, so I'm going to put 10, and I want you to enter it just how you see it. So 10 times, in parentheses, 3 to the power of x minus 1, close parentheses, and then it closes the parentheses for the sigma notation there, okay? It's going to give you 98,400. If you didn't get that answer, you probably entered it into the calculator wrong, so you need to make sure you enter it just like this. Okay, and then the last one, math 0, x 2 over to 10, and then 8x minus 15. 297. Okay? All right. So next, this says if an equals 2n minus 5 over n plus 3, then a12 equals, okay, so the 12 is your n. Okay, notice it says an, so 12, so n equals 12, and I'm just going to simply substitute this in. Notice they've already given you the formula. this is a explicit formula, so I could take whatever my value of n is and plug it into my okay. And once you've set it up, just put the whole thing in the calculator so you don't make any mistakes. So alpha y equals, so I have 2 times 12 minus 5, and then on the bottom 12 plus 3. So 19 over 15. And that's all you're doing. Okay. Because this is an explicit formula, it doesn't depend on any other terms, you can substitute directly n for n. Okay, next one. So I have if an equals n plus 3 over n plus 8, then a17 equals, so n equals 17 in this one. So then I'm going to substitute 17 plus 4 over 17 plus 8. Put it directly in the calculator. Alpha y equals 17 plus 4 over 17 plus 8. Gives me 21 over 25. Okay, let's go to the next page. Notice we haven't used our formula sheet yet, but we will in just a second. All right, what is a sub 6 in the sequence defined as follows? Okay, so again, we have another explicit formula that we're looking at. So we have n equals 6, and I'm going to substitute in 2 times 6 cubed plus 5 times 6 minus 9. I'm going to write all out first and then just plug it into the calculator. 2 times 6 to the power of 3, arrow over, plus 5 times 6 minus 9. 300 and okay, notice that I put minus 5, it's plus 5, so I'm going to retype that in. 10 times 6 to the power of 3 over plus 5 times 6 minus 9, which is 453. Okay, and what is a sub 4 in the sequence defined as follows? So I have n equals 4. I'm getting that from right here. That's where it's telling me that n is 4, and I'm going to substitute in 4 to the power of 3 minus 3 times 4 squared plus 5. Put the whole thing into the calculator. 4 to the power of 3 minus 3 times 4 squared plus 5. Which is 21. Okay? Alright. What is the sum of the first 10 geometric series 1 plus 2 plus 3, I'm sorry, 1 plus 2 plus 4, given the formula? Okay, so they gave us the formula. We see that we're summing and it's geometric, so we know we're multiplying something each time. So let's look at the things that we need. We need A1. They already gave us the formula, okay? We need A1. We know A1 means the first term, so that's 1. I need R. I don't see where R is, so I'm going to skip that. And then I need N, okay? N is the number of terms, so I have 10 terms, so N equals 10. R, okay, is my common ratio, so I need to figure out what am I multiplying each time here. Well, I'm multiplying times 2. 1 times 2 is 2, 2 times 2 is 4, and so on. So I know that my common ratio is 2. Once you have all of those pieces, all you're doing is plugging it into the formula. So S sub 10 equals A1, which is 1, times 1 minus R to the power of 10, all over 1 minus R. Okay? Once you have it filled out, just plug it into the calculator. You could try to do the pieces all together, but I just like to plug it into the calculator. So I have 1 times alpha y equals, 1 parentheses alpha y equals 1 minus 2 to the power of 10 over 1 minus 2. Arrow over, close my parentheses, and enter. 1023. So the sum of the first 10 terms in this geometric series is 1023. Okay, let's look at the next one. what is the sum of the first 12 terms of the geometric series 2 plus 10 plus 50 plus 250, given the following formula? So they've already given us the formula again. We're summing, okay? So I'm going to look here. I'm going to figure out what all my pieces are. A1 is the first term. That's 2. R, I'm not sure, so I'm going to skip that. N, it tells me this, I changed this. This is 12. 12 terms, so N is 12. Okay. R, I need to figure out what am I multiplying every single time. So 2 to get to 10, I multiply 5. 10 to 50, I multiply times 5. 50 to 550, you multiply 5. So your common ratio is 5. Now I'll just plug it in. S sub 12 equals A1 is 2, 1 minus R to the power of N over 1 minus R. Okay, and remember, we're looking for the sum of the first 12 terms in the series. So instead of just adding them all up, we're just going to plug it into that formula. So 2 parentheses alpha y equals 1 minus 5 to the power of 12 over 1 minus 5. Enter. Big number. So 1, 2, 207, 0312, comma, comma. Okay? Alright, let's keep going. Given the formula Sn, S sub n equals n over 2 times the quantity 2 times a sub 1 plus d, which is our common difference, times the quantity of n minus 1. The sum of the first 12 terms of the arithmetic series. Okay, so again we're adding, but this time it's the arithmetic series. Again, they've already given us the formula, so they've kind of done the work for us. So let's look at all the pieces we need. I need to know what n is. Well, they told me the first 12 terms in the series. I need a sub 1. That's my first term, which is negative 2. I need d, which is my common difference. I don't know that, but if we look at this pattern, what are you adding every single time? Negative 2 to negative 7. Negative 7 to negative 12. You're adding negative 5. And double check to make sure it's right. Negative 2 plus negative 5 is negative 7. Plus negative 5 is negative 12. Plus negative 5 is negative 7. So I know that d is negative 5. And it can be a negative number. You can be adding a negative number each time. Okay? Alright, so let's plug into the formula. S sub 12 equals n over 2 times 2 times the first term, which is negative 2, plus d, which is negative 5, times n, which is 12, minus 1. Okay? I'm going to put that whole thing into the calculator again. Alpha y equals 12 over 2 times 2 times negative 2. Careful, make sure you put negative, not minus. Plus negative 5 times 12 minus 1. And remember to close your parentheses again at the end. That's going to give me negative 354. And again, you can do this piece by piece if you want to work out the steps algebraically. I just plugged it all into the calculator. Just make sure when you're putting in the calculator, because you opened a parentheses over here on this side, that you close it on this side. Okay? All right, we have very similar. So given the formula, sum of the first 27 terms of the arithmetic series. All right, so things I need. I need n. N equals 27. Okay? I need a sub 1, which is my first term, which is 2. And then I need my common difference. So I have to look, what am I adding every single time? All right, so it looks like you're adding some fraction. Okay, so if it's hard to see, kind of the trick is to go backwards. So I'm looking for what am I adding each time, but you could go backwards to figure out what you added. And to do that, you could do alpha y equals 7 over 3 minus 2. So this tells you that I added 1/3 every time. So remember, when you're moving this way, you're saying, what did I add each time? But if it's a difficult one to see what you added, you can go this way, okay, And you could say, well, I'm going to see what I subtracted. So I subtracted the first two terms. So it looks like I'm adding 1/3 each time, but let's check. So 1/3 plus 2 gives me 7/3. Plus, let's see if it works for the next one. Adding 1/3 again gives me 8/3. So I am adding 1/3 each time. So my common difference is 1/3. Okay, we're going to plug it into the formula. S 27 equals n, which is 27. I'm just substituting in. Divided by 2 times 2 times a sub 1, which was 2, plus my common difference, which was 1/3, times 27 minus 1. Okay, and I'm going to put that whole thing into the calculator just like that. Okay, so alpha y equals 27/2, open parentheses, 2 times 2 plus alpha y equals 1/3 times 27 minus 1. Now remember, we opened that original parentheses, so I've got to close it over here. Gives me 171. So as long as you know how to find all those pieces, this really is just substituting and plugging into the calculator, at least these first few. All right, let's look at the next one. The first three terms of an arithmetic sequence are 30, 26, and 22. What are the 9th and 10th terms of the sequence? Okay, so it's asking for the 9th and 10th term. All right, so if I look here, I know it says that I've arithmetic, and I'm looking for the 9th and 10th term. So it looks like it's an explicit form. So this is the formula I'm going to use. I know it's not sum because it's not adding, and it didn't say anything about it being recursive, so it has to be explicit. So I'm going to use an equals a1 plus n minus 1 times d. Okay. Once we figure that out, now we need all the pieces. A1 equals 30. N equals, well, we have two different ones we're looking at. N equals 9, but we also need to evaluate n equals 10. Okay, so we're going to have to do both of them. We're going to have to do 2. And then I also need to know what D is. So I'm looking for, what am I adding every single time? All right, well, the numbers are going down, which means I'm adding a negative number. So let's see what the difference is between 30 and 26. 4. So it looks like I'm adding negative 4 each time. 30 plus negative 4 is negative 26 plus negative 4 is negative 22. So I am adding negative 4 each time. Okay, so now I'm going to plug in. So have a, let's do, remember we've got to do this twice, so let's do 9 first. A sub 9 equals my first term plus, n is going to be 9 this time, minus 1 times negative 4. But then remember, I also need to do a sub 10, so that's going to give me my first term plus 10 minus 1 times negative 4. And be careful, that is times negative 4. All right, now I can plug that into the calculator. 30 plus 9 minus 1 times negative 4. It's going to give me negative 2. Now, you could plug it back into the formula, but if this is my 9th term, negative 2, I should just be able to add negative 4 to get my 10th term, which is negative 6. Let's see if it works, though. Let's look. I have 30 plus 10 minus 1 times negative 4. Oh, look, it's negative 6. It worked. Perfect. All right, next one. The first three terms of geometric sequence are 3, 6, and 12. What are the 6th and 7th term in the sequence? Okay, so kind of similar question, except it says geometric. All right, so let's look. Didn't say anything about recursive, and we're not summing anything, so we know that this is the formula we have to use right here. So I'm going to write that down. A sub n equals a1 times r to the power of n minus 1. All right, let's look at our pieces. I have a1, which is 3. R, I'm not sure. And then n, I have to look at n equals 6, and I also have to look at n equals 7. So let's look at r. So because it's geometric, I'm saying, what am I multiplying every time? What am I multiplying to get to 6? Well, I multiply 2. 3 times 2 equals 6. What am I multiplying to get to 12? 2. Okay, so my common ratio is going to be 2. Now we're going to plug in. So for the first one, we have a sub 6 equals 3 times 2 to the power of 6 minus 1. But then I also need a 7, which is 3 to the power of 2 times 7 minus 1. I've got to evaluate both of those. Okay, let's plug that into the calculator. So I have 3 times 2 to the power of, to the power of 6 minus 1. Okay, so that's going to give me 96. Now remember, because we're at the 6th term, the 7th term, I should be able to get it by multiplying times 2, which hopefully it's 192, but let's just double check. So I have 3 times 2 to the power of 7 minus 1, which is 192. Now, what I want you to be careful of here, this is where you're going to make a mistake. You cannot multiply this 3 times 2. Remember order of operations, so that I have to do exponents before I multiply. So you have to evaluate this part first before you multiply times this 3. So please do not multiply 3 times 2 and then take it to the power of whatever n minus 1 is. Okay? And that's it for page 1 and 2.